Hi friends, in the previous video we discussed about designing a Turing machine for the language A raised to n, B raised to n, C raised to n. In this video we will construct transition diagram for the same, where Turing machine M consists of Q summation tau delta Q naught B F, where the number of states needed, as we discussed in the previous video, are Q0 to Q6, where Q0 is the initial state and Q5 is the final state. Input symbols are A, B and C. Tape symbols are A, B, C and X, Y, Z. As you know, A is replaced as X, B as Y and C as Z. Initial state is Q0, blank is represented by B and Q5 is the final state. Let's design the transition diagram keeping A raised to 3, B raised to 3, C raised to 3 in the head. Initial state Q0 pointing to the first symbol, that is A. A is replaced as X. Q0, A is replaced as X. Move towards the right. Change the state from Q0 to Q1. And go on moving towards the right, keeping the input symbols in the tip as it is, keeping the state Q1 until we come across a first B. So Q1A ends here. Keep as it is, be in the same state, move towards the right. Once you get a B, B is replaced as Y. State is changed from Q1 to Q2 and move towards the right. And keep B as it is and go on moving towards the right until we get the first C. Once we get a first C, C is replaced as Z. State is changed from Q2 to Q3 and move towards the left. Move towards the left until we come across a first A. So now you can see here at Q3, B, keep B as it is, move towards the left. Keep B as it is, move towards the left, be in the same state. Keep Y as it is, be in the same place. Q3, move towards the left. Keep A as it is, move towards the left until we come across X. Once we come across X, keep X as it is, move to the right and reset the state to Q0. This completes one cycle. Again, Q0A, A is replaced as X. Already we have a transition. Move towards the right, change the state to Q1. In Q1, A is kept as it is, move towards the right. Now if I come across Y, Y also must be kept as it is. So a self loop, Q1Y and move towards the right. Now once we come across the first B, what to do? B is replaced as Y. Change the state to Q2 and move towards the right. In the right, keep all the B's as it is. And now Z also as it is. So we have one more transition. Z, self loop, move towards the right. Once we come across a C, C is replaced as Z. Change the state from Q2 to Q3 and move towards the left. In the left, go on moving left until you get a first X, being in the same state Q3. So in Q3 until I get X, I come across Z, B, Y and A. So B, Y and A are there. Z, one more transition I must add to move back being in the same state until I come across X. So once I come across X, Q3X, what I'll do? Keep X as it is, move towards the right and reset the state to Q0. So again, Q0 A, it will replace A by X, move to Q1, keep as it is, move towards the right. B is replaced as Y, change the state to Q2, go on moving towards the right until you come across a C. C is replaced as Z. Change the state to Q3 and move towards the left until we come across the X. Now once we come across the X, now you can see here Q3, X is kept as it is, change the state from Q3 to Q0 and move towards the right. Now in the right, if you see, we have Y, whereas here we have A. When we have Y, it means what? All A's are exhausted. It means all B's are also exhausted, all C's also exhausted. It means towards the right, I must have either Y's or Z's. So Q0 Y will have, keep Y as it is, move towards the right, change the state to Q3. All the Q0 Y's, Q4 Y's, keep as it is, move towards the right. If you come across Z also, be in the same state, keep on moving. Q4Z, be in the same state, move towards the right. Be in the same state, move towards the right until you come across a blank. So once you come across a blank, change the state Q4 to Q5, keep blank as it is, move either towards the left or towards the right, and Q5 is the final state or accepting state. So this is the transition diagram obtained for this particular Turing machine. Once we obtain the transition diagram, it is very simple to derive the delta transitions. Initial state Q0 for input A, it going to state Q1, A is replaced as X, move towards the right. This is one transition. One more transition from Q0 is going to Q4, Y is kept as it is, move towards the right. So only two transitions from Q0. Coming to Q1, Q1 is taking a self loop for A and Y. Q1A self loop, keep A as it is, move towards the right. Similarly for Y. Q1B is going to Q2, B is replaced as Y, move towards the right. So we have totally three transitions from Q1. Coming to Q2, Q2, B and Z takes a self loop, move towards the right. And for C, C is replaced as Z and move towards the left. Change the state from Q2 to Q3. In Q3, A, B, Z and Y. A, B, Z and Y take a self loop. And for X, it changes the state from Q3 to Q0, keeping X as it is and move towards the right. Q4 takes a self loop for Y and Z, keeping the tape symbols as it is, moves towards the right. And once it comes across a blank, move left or right, it reaches the final state, where Q5 is the final state. So these are the delta transitions obtained for this Turing machine, A raised to n, B raised to n, C raised to n. Thank you.